Hello students, this lesson is on tests for cations. What will you be learning in this lesson? You will learn how to identify the following cations using two important reagents. They are aqueous sodium hydroxide and aqueous ammonia. However, aluminum ion has been taken out of the syllabus. Cations are identified based on their reactions with two reagents, aqueous sodium hydroxide and aqueous ammonia. Please note that the chemical name of aqueous ammonia is ammonium hydroxide with the chemical formula NH4OH. All the cations except ammonium ion reacts with the hydroxide ion in aqueous sodium hydroxide and aqueous ammonia to produce precipitates. First, let us recall what is a precipitation reaction. It is a reaction whereby two aqueous solutions react to form an insoluble solid. This insoluble solid is known as the precipitate. Now, let us look at an example. For solution 1, let's say we use aqueous sodium hydroxide, and for solution 2, we use copper 2 chloride containing the cation Cu2+. This reaction produces copper 2 hydroxide and sodium chloride. The insoluble solid formed here is copper 2 hydroxide, which is known as the precipitate, or in short, PPT. Metal cations can be identified by the color of the precipitates formed and their solubility in excess of the reagent, which is aqueous sodium hydroxide or aqueous ammonia. Ammonium cation can be identified by production of ammonia gas when aqueous sodium hydroxide is added. Can you recall the acronym ASSAW? AASSAW? When an alkali, for example sodium hydroxide, is added to an ammonium salt, ammonia gas is produced as one of the products. We need to test for the ammonia gas produced by placing a damp red litmus paper near the mouth of the test tube. The red litmus paper will turn blue in presence of the ammonia gas. This flowchart is a summary of the cation table. When aqueous sodium hydroxide or aqueous ammonia is added, a solution containing copper 2+ will give a blue PPT. A solution containing iron 2+ will give a green PPT. And a solution containing Fe3+ will give a reddish brown PPT. There are 4 cations that will give a white PPT when aqueous sodium hydroxide or aqueous ammonia is added. They are Pb2+, Al3+, zinc Zn2+, and Ca2+. We will elaborate more on this acronym in the next slide. Group 1 metal, ammonium cation, do not form any precipitate with sodium hydroxide or aqueous ammonia. As mentioned in the previous slide, there are 4 cations that give a white PPT when aqueous sodium hydroxide or aqueous ammonia is added. They are Zn2+, Pb2+, Al3+, and Ca2+. However, as mentioned earlier, Al3+ is out of the syllabus. We can make use of these acronyms to help us remember the solubility of the PPT in excess aqueous sodium hydroxide and in excess aqueous ammonia. They are SSZ, SIP, and INC. The first column represents the solubility in excess sodium hydroxide. The second column represents the solubility in excess aqueous ammonia. And the last column represents the cation. S means soluble, I means insoluble, N means no PPT. For example, the cation Pb2+ forms a white precipitate which is soluble in excess sodium hydroxide. And insoluble in excess aqueous ammonia. Let us go through these 3 questions together. It is a good practice to highlight important information like the color of PPT, solubility of PPT in excess sodium hydroxide or aqueous ammonia, and any gas produced when reducing the cation. This question forms a white PPT insoluble in excess aqueous ammonia to form a colorless solution. Let's refer to the flow chart to identify the cation. Referring to this flow chart, the cations that form white PPT are Pb2+, Al3+ is out of syllabus, next Zn2+, and Ca2+. So the possible cations for this question are Pb2+, Zn2+, and Ca2+. Which one is the answer? We'll need to see the solubility of the PPT in excess of the reagent used. In this case, the PPT was insoluble in excess aqueous ammonia. Choosing the second column, which is the solubility of the PPT in excess aqueous ammonia, we can tell that the cation in this case is Pb2+. Now let's go to the second question. Let's highlight the color of PPT, reddish brown PPT, insoluble in excess aqueous sodium hydroxide. To deduce this cation, we refer back again to the flowchart. The only cation that forms a reddish brown PPT with aqueous sodium hydroxide is Fe3+. Therefore, we can deduce the cation here is Fe3+. Alright, let's go to the final question. No PPT was formed when aqueous sodium hydroxide was added, and no ammonia gas produced when the mixture was heated. What are the cations that do not form any PPT with aqueous sodium hydroxide or aqueous ammonia? The cation could be a metal 1 cation, or it could be a ammonium cation. In this case, no gas was produced upon warming, so we can deduce that the cation is a group 1 metal. We can state the cation as Na+ or K+. That's the end of the lesson. Thank you.